Hello students, in this video we are going to derive few formulas for simple harmonic motion. So we know that oscillating spring is related to uniform circular motion because the ball which is revolving around certain center or axis behaves in the same way how the mass behaves in this our mass spring system. So let's get started. In this video we are going to derive formula for displacement, velocity and acceleration in this simple harmonic motion. So here we will make the shadow or projection of this what is revolving. So we will make this is the shadow or projection of that shadow. So now the displacement along the x-axis will be given by what? As we have studied in circular motion, you can go and watch my previous video. So x will be given by x0 cos theta. x0 is the maximum displacement. x0 is what? Maximum displacement. And also you know that omega is given by theta upon time. So theta is angular displacement, which is shift angle, will become equal to omega into t. So here we can now omega into t is equals to theta. So we can substitute this theta with omega into t. So the equation will become displacement will be equals to maximum displacement cos theta, and then instead of theta we will rub this theta and we will write here as omega into time. So this is the first formula which we have derived for our displacement. So now we will move ahead and derive other parameters. Now we are going to take down this triangle is there, this purple color triangle, this triangle which is formed, this is the triangle. We are going to take it down and we will derive another parameter for this. So we have actually taken this triangle down, this one, and we have turned it upside down. This yellow color triangle is what we have turned it upside down, this triangle. Now we are going to solve and derive another parameters for this. Now we are going to see in our yellow color triangle, as you can see, velocity will be given by maximum velocity into sine theta, but the sign here will be negative. Why? Because it is pointing towards the left side. So that's why it is going to be negative. So that's why we have written here as minus. So this you should remember, it should be in minus. And again we know that theta is equals to omega into time. So we can substitute this theta with this. So velocity will be equals to maximum velocity into sine omega into t. So here this formula will become velocity will be equals to maximum velocity into sine omega times t. So this is the formula for velocity. So now we are going to derive acceleration, the most important parameter for this. So acceleration will be given by, we can see in this yellow color triangle, it will be given by maximum acceleration cos theta. And sine, you should remember the sign should be negative because it is pointing towards the left. Now again we know theta is equals to omega into t. So here omega into t, so we can write this acceleration, centripetal acceleration, and centripetal acceleration is given by maximum displacement into omega square. Now we can substitute here centripetal acceleration, we can substitute this value in this equation number 1. So this equation number 1 will become acceleration equals to, instead of minus AC we will write minus maximum displacement omega square, this value we will write, and then we will write cos theta. Now we can substitute even cos theta because cos theta is given by omega into t. This is our second equation. So we will substitute this omega into t with this cos theta. So acceleration will be given by acceleration will be given by, so here I will write acceleration will be given by x0 maximum displacement into omega square cos, then instead of theta we will write omega into t, so omega into t. So this is the formula for acceleration which we have derived. I will write this formula on the next page. So acceleration is equals to minus maximum displacement omega square cos omega into t. But we know that x maximum displacement, we have derived this in previous equation, x0 cos omega t. So I am talking about this one. I am talking about this which we have derived for the first equation which we have derived. So we know this, x equals to x0 maximum displacement cos into omega into t. So in the equation number 1, that is acceleration's equation, we will bring x0 and cos omega t together. So now we will write this acceleration equals to minus x0 cos omega t, and this omega square we will write separately into omega square. Now as you can see in the second equation, x means displacement is given by maximum displacement into cos omega t. So here it is same, so we can substitute this too, this as x, this we can substitute as x. So we will write acceleration equals to x into, and minus sign is there, omega square. So this is the important parameter of acceleration which we have derived from this equation. But remember important point here, that this derivation works only when the mass begins at x is equals to plus x0, that is amplitude maximum displacement, and at time, initial time, that is t, at time equals to 0 seconds, and the cos graph is there. What we have done, it gives the information about displacement, that is x, means when mass begins at x equals to 0 and time is at 0 seconds. So this derivation works for that type of simple harmonic motion. Now we are going to revise what we have derived. Okay, so first of all we have derived the displacement. So displacement is given by x0, that is maximum displacement, into cos omega t, and we have derived the displacement even by this formula, x0 maximum displacement into sine omega t, where omega is given by 2 pi upon t. So we have derived displacement here. Now we have again derived velocity also we have derived. So velocity will be given by, what we have derived is maximum displacement, negative maximum displacement, omega sine omega t, and this velocity also we can find using our cos value as minus maximum velocity in sine theta. So we have derived this velocity. These formulas you need to know while solving the sums. We have also derived acceleration, two formulas for acceleration. The first formula which we have derived is minus maximum displacement into omega square cos omega t. So in terms of our vertical component and horizontal component, so it will become x0 omega t, even sine theta for horizontal component omega t. So this is for vertical component and this is for horizontal component. So we have derived these two equations. For vertical, that is x-axis, x component, and this is y component. Y means vertical component and x means horizontal component. We have derived our main formula for acceleration, that is given by negative of omega square into displacement. These are the three important parameters which we have derived for simple harmonic motion. Now in the next video we will be deriving this using our calculus, so it becomes very easy. It is not so much complicated how it was here. Here we have used the trigonometric ratio, but in using calculus it becomes little bit more easier than this. So bye for now.